The balance of naval power in the Pacific has steadily shifted over the past decade, driven by the rapid advancements in technology for China's People's Liberation Army Navy, or the PLAN, and the sheer industrial output and shipbuilding capacity available to that navy. The United States Navy remains the largest in terms of tonnage and the number of missiles. But we have seen the rapid shrinking of the qualitative gap between the US Navy and the PLAN. While the modernization and expansion of the PLAN cuts across a comprehensive range of naval assets, including aircraft carriers, amphibious warfare, submarines, and unmanned systems. In this video, we focus on how China's best destroyers compare to the most capable destroyers in the US Navy. The PLA Navy's premier surface combatant is the Type 055 large destroyer. Formerly designated by NATO as the Renhai class and by the US Navy as a cruiser, the Type 055 represents the culmination of decades of Chinese naval modernization. To understand its lineage, one must look back to the Type 052C, which was China's first truly capable indigenous air defense destroyer, featuring fixed-panel, active electronically scanned radars and a vertical launching system. This design was subsequently iterated into the widely produced Type 052D destroyer. The Type 055 builds directly upon this evolution, stepping away from incremental upgrades to establish a massive clean sheet platform that carries heavy firepower and sensory capabilities across air defense, anti-surface warfare, and anti-submarine warfare. Across the Pacific, the United States Navy responded not with a brand new destroyer design, but by pushing its most reliable and proven platform to its absolute physical limits. This is the Arleigh Burke class Flight 3 destroyer. To put the Flight 3 in context, it helps to understand the history of the Arleigh Burke flight. The original Flight 1 and Flight 2 variants entering service in the 1990s were optimized for open ocean, area air defense, and land strike missions. The subsequent Flight 2A introduced a double helicopter hangar and expanded the vertical launch capacity to 96 cells. Many Burkes were subsequently improved with anti-ballistic missile defense capabilities, although the Aegis software upgrades enabling this varied in terms of capability. As threats evolved and the ambitious next-generation cruiser program was cancelled, the US Navy chose to radically re-engineer the internal systems of the existing Burke hull. The resulting Flight 3 architecture transforms the vessel from a traditional air defense escort into a more balanced multi-role platform with significant offensive capabilities in peer-level naval conflict. When evaluating the respective effectiveness of the Type 055 and the Arleigh Burke Flight 3, it is vital to emphasize that modern naval warfare is not a 1 versus 1 duel. Neither the Type 055 nor the Arleigh Burke Flight 3 is designed to operate in isolation. Instead, both destroyers are explicitly engineered to function as the protective core or the primary offensive spearhead of a larger naval task group. A hypothetical combat encounter occurring in isolation fails to capture the true strengths and operational realities of either vessel, as their true capabilities are realized through sensor fusion, network data, and cooperation with aircraft carriers, submarines, smaller surface combatants, and land-based support networks. A direct comparison of the primary volume search radars reveals that both nations have reached a highly mature technological baseline. Both ships utilize 4 fixed radar faces integrated into their superstructures to provide continuous 360-degree airspace surveillance. Furthermore, Both classes rely on Advanced Active Electronically Scanned Array, or ASAR technology, built around gallium nitride semiconductor modules. The Type 055 features the Type 346B Dragon Eye radar, which operates primarily in the S-band for long-range volume search, augmented by C-band elements for target illumination. The Type 346B is a massive upgrade over the older Type 346A found on the Type 052D, indicating that Chinese ASAR technology is now established and mature. Meanwhile, the Arleigh Burke Flight 3 uses the AN-SPY-6 air and missile defense radar. This is an S-band ASAR radar built from large numbers of radar modular assemblies and delivers up to 30 times the sensitivity of the legacy SPY-1 radar found on previous flights of Arleigh Burkes. The shift to ASAR radars represents a massive improvement over the previous generation of passive electronically scanned array, or PSAR systems, like the older American SPY-1 radar. A PSAR radar is inherently constrained by its passive architecture, where a single central transmitter generates the radar signal. Even though the array elements can steer the resulting radar beam incredibly fast, a PSAR system can fundamentally only form a single primary beam at any given microsecond. While a PSAR radar can still track multiple targets, it is generally limited to handling one primary task per scan cycle. In stark contrast, ASAR radars distributes thousands of individual transmitters across the entire face of the array. Each individual antenna element features its own independent transmitter and receiver module, allowing the radar to generate and process multiple independent beams simultaneously in entirely different directions. This capability exponentially increases radar sensitivity, updating speeds for tracked targets, and resistance to electronic jamming. However, this immense performance comes at a cost, requiring a huge surge in electrical power generation and heavy-duty liquid cooling infrastructure to prevent the radar arrays from overheating. Beyond long-range tracking, both the Type 055 and the Burke 3 carry secondary surface search radars optimized for tracking low-altitude, sea-skimming anti-ship missiles. The Type 055 utilizes the Type 368 ASAR radar, which is mounted high atop its fully enclosed integrated mast. The Arleigh Burke Flight 3 relies on the AN-SPQ-9B mechanically rotating radar. Both systems operate within the high-frequency X-band, which provides the tight resolution necessary for close-range targets tracking and fire control. However, the Chinese Type 368 ASAR radar is functionally superior to the American equivalent. Because the Type 368 is an electronically steered array rather than a mechanically rotated radar, it can refresh tracking targets near instantaneously without the mechanical latency of a rotating antenna, while also managing multiple independent beams to counter low-altitude saturation attacks. This more modern approach extends to close-in points defense. The Type 055 features the Type 1130 close-in weapon system, an 11-barrel rotary cannon capable of firing over 10,000 rounds per minute, creating a devastating dense wall of metal. This represents a more modern and higher volume points defense than the older phalanx system found on the Arleigh Burke Flight 3. In traditional air defense, the two destroyer classes possess broadly comparable long-range intercept capabilities. The primary Chinese long-range surface-to-air missile is the HHQ-9B, which matches the American Standard Missile 6, or SM-6, across several key technical parameters. Both missiles rely on an active radar homing seeker in the terminal phase, meaning they can track and strike a target independently without requiring continuous radar illumination from the launching ship. Both use solid fuel rocket boosters paired with solid sustainer motors, achieving comparable top speeds between Mach 3.5 and Mach 4, and both feature an estimated maximum engagement range of roughly 300 kilometers. However, the US Navy holds a distinct mature advantage in medium-range air defense depth through its quad-packing technology. The US Navy has spent decades refining the capability to pack 4 evolved Sea Sparrow missiles into a single vertical launch cell, massively expanding its defensive magazine depth. While China possesses its own quad-packable missile, frequently referred to as the 555 missile, this capability remains in its early deployment stages, and arguably lacks the operational maturity and widespread integration found in the American Arleigh Burkes. A stark divergence appears when analyzing anti-ballistic missile defense capabilities. The Arleigh Burke Flight 3 is unequivocally superior in this specific domain. It is natively equipped with the standard Missile 3 interceptor and runs the Aegis Baseline 10 combat system, which are purpose-built to track, engage, and destroy ballistic missiles outside the atmosphere during the mid-course of the ballistic missile flight. Conversely, while China has developed a capable land-based anti-ballistic missile defense system known as the HQ-19, this system has not been adapted or deployed across the PLAN fleet. As a result, the Type 055 has no dedicated anti-ballistic missile interceptors in its inventory. However, this absence of dedicated weaponry must be viewed through a doctrinal lens. The Type 055 operates in an environment where it faces very few naval ballistic missile threats, primarily needing to contend with shorter-range tactical ballistic missiles, like the American ATACMS. The Arleigh Burke Flight 3, by contrast, operates under the constant shadow of China's lethal, highly advanced inventory of land and ship-launched anti-ship ballistic missiles, including the DF-21D, the DF-26, and DF-17 anti-ship missiles. The Burke 3 requires much greater ballistic missile defense because it's expected to face ballistic weapons at a much greater frequency and severity than the Type 055. And the Type 055 is not defenseless against ballistic missiles either, because traditional air defense will provide some degree of ballistic missile interception, even if less effective than dedicated defensive systems. When the scenario shifts to offensive anti-ship warfare, the advantage tilts decisively in favor of the Chinese vessel. The Type 055 is a heavily armed surface-to-surface striker, carrying a comprehensive mix of the supersonic YJ-18 cruise missiles and the hypersonic YJ-20 anti-ship ballistic missiles. This offensive dominance is made possible by the physical design of the Chinese universal vertical launching system. All 112 cells on the Type 055 are constructed to full strike length, measuring 9 meters deep and 0.85 meters wide. This makes them significantly deeper and wider than the strike length variants of the American Mach 41 vertical launch system, which is limited to 7.7 meters in depth. The extra physical volume allows the Type 055 to launch much larger, faster, and heavier anti-ship weapons. In comparison, The Arleigh Burke Flight 3 must rely on the Tomahawk Block 4 and 5 missiles for long-range anti-ship strikes, while the Block 5 introduces a more capable radar seeker that tracks moving vessels at sea. The Tomahawk remains a subsonic cruise missile. It lacks the sheer terminal speed, kinetic energy, and the ability to penetrate naval defenses of China's supersonic and especially its hypersonic anti-ship missiles, giving the Type 055 a massive edge in surface-to-surface engagements against other ships. In the underwater domain, anti-submarine warfare capabilities reveal another divergence. On paper, both ships feature a double helicopter hangar and deploy airborne assets with similar quality. The Type 055 operates two Z-20F helicopters, while the Arleigh Burke Flight 3 deploys two MH-60R Seahawk helicopters. These two helicopters are close in terms of physical size, estimated takeoff weight, dipping sonar capabilities, and the size of their sonar buoy payloads, making them roughly equivalent submarine hunters. Furthermore, both warships can fire long-range, rocket-propelled anti-submarine torpedoes from their vertical launch cells, utilizing the Chinese U-8 missile and the American vertical launch ASROC, respectively. However, the Type 055 holds a distinct advantage in terms of organic shipboard sonar. Both destroyers are equipped with a high-fidelity, hull-mounted bow sonar and a long-range, passive towed array sonar to detect distant underwater threats. Yet, the Arleigh Burke Flight 3 lacks a variable depth sonar, an asset that is natively integrated into the stern of the Type 055. A variable depth sonar allows the Type 055 to lower an active sonar below the ocean's thermal layers. This capability allows the Chinese vessel to detect deep-diving hostile submarines that are hiding in the thermocline, an operational advantage that a ship relying solely on hull-mounted or standard towed array sonars will struggle to replicate. Signature management and stealth capability represents another area where the difference in the age of the respective designs becomes highly visible. The Type 055 features a modern clean-sheet hull designed for low observability. It features smooth, continuous lines, an enclosed forecastle that completely conceals mooring lines and anchor chains, an enclosed integrated radar mast, and cooling channels built into the smokestacks to actively suppress its infrared signature. The Arleigh Burke Flight 3 features various signature reduction measures, including angled superstructure panels and exhaust suppression systems. However, its core configuration fundamentally dates back to a late Cold War architecture that predates the era of purpose-designed stealth warships. Its open tripod mast, exposed deck equipment, and complex structures create a significantly larger radar cross-section than the sleek Chinese vessel. This design disparity means that, in a contested environment, the Type 055 is likely capable of closing a greater distance and operating closer to opposing forces before it can be reliably detected and tracked by enemy search radars. Weighing these diverse technical aspects reveals two distinct platforms optimized for different tactical requirements. The Arleigh Burke Flight 3 is a well-balanced and mature air defense asset. Its supremacy in anti-ballistic missile interception and its highly refined, combat-proven quad-packing capability make it arguably the more capable option for protecting high-value capital ships from a range of aerial threats. The Type 055, on the other hand, emerges as the more capable, all-round surface combatant. It leverages its larger and more numerous vertical launching cells to deliver overwhelming offensive firepower through its hypersonic and supersonic anti-ship missiles. The Type 055 also appears to be the individually more survivable platform, owing to a clear advantage in close-range radar tracking and points defense, to a more comprehensive sonar suite, and owing to a superior stealth profile. At the same time, the Type 055 is still very capable in traditional air defense against non-ballistic threats, even if less well-rounded than the Burke 3. Ultimately, these capability differences are a direct reflection of different naval doctrines. The United States Navy views its destroyers primarily as defensive escorts. Their core mission is to form a protective umbrella around a supercarrier, allowing the carrier's air wing to act as the offensive hammer of the fleet. The Chinese PLA Navy certainly tasked the Type 055 with defending its own aircraft carriers, but its doctrinal scope is much wider. The Type 055 is expected to act as an independent offensive platform, capable of leading independent surface action groups and destroying opposing ships using its own missile magazine. The Burke Flight 3 is designed to protect the fleet's ultimate weapon, while the Type 055 is designed to be that weapon itself. If you are interested in learning more about China's Type 055 destroyer, please watch this video on your end screen right about now. See you next time.